Okay, so in the last video I showed you what casting is. Now I'm going to show you how to cast. So first I'm going to show you implicit. And if you don't remember what implicit means, right when I say that, go back and watch the last one again. Take some notes, okay? So this is implicit. So I'm going to make a double. A equals 100. I'm sorry. Oh yeah, and an integer b equals 2. No, let me do this. Let me do this. This is we're doing implicit first. And double. 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 Okay. Okay. So we're going to cast A to BB. B is a double, has the value of A. No problem here. Okay. This is implicit. It's implied, right? And check this out. Notice it has that decimal place with nothing right there, right? I'm going to print out A, and then I'm going to print out B. So A is an integer, and it's 100. Integers don't have decimals, so there's no decimal when you print. We implicitly convert this to a double. There's no loss of information, right? So this is a double. We convert it flawlessly. No loss of information. So it slaps that decimal onto the end. There's enough room to have a decimal, but it doesn't have a decimal. And when we print that out, when we print out a double, there is a decimal. Okay? This is implicit. You could also do this with a char to an int, but I'll show you that in a second. You could do it the other way, though. You could say double A equals 100.56. Okay? And int B equals A. See what happens here. It yells at us, right? Lossy conversion from double to int. It's saying, dude, you're going to lose information if you convert this, right? This is narrowing. Okay, we have to be explicit when we convert from a larger data type to a smaller data type. And the way that we do this is we say, convert it, Java, convert it. We're explicitly telling it. You do parentheses with the type right next to the thing you want to convert. Java will say, okay, you're a loss. You're a loss. Oh, sorry, not double, int. Right, we're converting it from a double to an int. So A has the double in it, and B is that double converted to an integer. Now notice we lost information here. Maybe that's okay. You know, I'm gonna actually have something where I'm gonna have a problem for you where you have to do this. Okay. So the other thing is you can actually convert an int. Int A equals let's do 100, and int B equals, I'm sorry, not int. We're gonna do it char. We're gonna convert an integer into a char. Okay, A converted, casted to a char. Okay, actually, I'm gonna do 84. Let's do 84. I know what character that is. We're gonna take the number 84, the binary representation of 84, and we're going to interpret it as a character. System out print line A, and we're going to system out print line B. And this is this narrowing or widening? This is narrowing, right? Ints are bigger than chars. You're compressing it down, right? So why does this print T? Well, if we look up at the ASCII table, and we go to, what number? 84. We go to 84, that's T, right? So we took the number 84 and we converted it to the character representation. And you can do that the other way, right? You could take some character, let's say I have char A equals X. You could convert it to an int. Now, can you do this implicitly or do you have to do it explicitly? Let's see. It happens implicitly because chars are smaller than ints. Okay, you're going to have to use this for one of your assignments. Hopefully you understand this. Ask me some questions if you don't.